Alright guys, welcome to this page of the notes. Now, let's take some time here and talk about our second objective or learning target, which is the factor theorem of polynomials. And here's what we just discovered. We just did a problem where I took this polynomial, right, and I did synthetic division by this polynomial, this binomial, x plus 3. And when I did the synthetic division, I got a remainder of 0, which tells me x plus 3 is a factor of this polynomial, which is exactly what I explained to you right here, right? Since the remainder is 0, right? If I were to plug a negative 3 into the function, right, it equals 0. This means x plus 3 is a factor of this polynomial, right? The polynomial that I gave you in the previous example problem. This illustrates for us the factor theorem. And here's how we're going to use the factor theorem. The factor theorem can be used to determine whether a binomial is a factor of a polynomial. We'll do synthetic division. If you get a remainder of 0, you know that that binomial, right, that binomial, you'll know that binomial is a factor of the polynomial you were given. Awesome. So what? Well, here's what. It can also be used to determine all of the factors for the polynomial, which is a really big deal because we're trying to find the zeros, the x-intercepts of a polynomial. And in order to do that, you need to be able to factor the polynomial. And so what we've got here now is a theorem, the factor theorem, that is yet another method for allowing us to find the factors of a polynomial. Let me show you how this works real quick. This is the exact same example problem. You guys can clearly see, right? It's the same problem we just did, right? Right here on this page of the notes, right? I did this problem for you guys right here. Same problem. I haven't changed anything. All I've done is rewritten it. So this synthetic division right here, I've just rewritten right here, right? Same. There is a small typo, though. This should be an x cubed. I apologize for that. Just scratch that guy out and put an x cubed right up there. Okay, but here's the way this is going to work. I gave you this polynomial and this binomial, right? We did the synthetic division, right? We got a remainder of 0, which tells me, hey, x plus 3 is one of the factors for this polynomial. What's left over, I can then use to write my quotient. So here we go. I have, remember, your quotient is always 1 degree less than the polynomial you were originally given. Since it's a third degree polynomial, my quotient is going to be 2x squared minus 9x plus 10. All right, so that's my quotient. That's my quotient, one of my factors for this original polynomial, and I also know that x plus 3 is one of my factors. So I'll keep that guy, x plus 3. Now, here's why I can write it like this. Again, if you were to take the time to multiply all this stuff out using the distributive property, right? You multiply these two quantities together, you're going to get right back to what you started with. So what I've done is I've factored this original polynomial where one of my factors is that x plus 3. I know that because I wound up with a remainder of 0. And just a quick definition for you. I've been saying the term a couple of times throughout these videos. Here's where you get the definition for it. The quotient is called a depressed polynomial. Depressed because it's 1 degree smaller than the original polynomial you were given, right? This was a third degree polynomial. I did my division. I got a polynomial, a quotient that is 1 degree less, a depressed polynomial, all right? So that I've been using that term a little bit. Here's your definition for it, depressed polynomial. So here's what I'm going to do. Head on over to the next page of the notes. I will work through an example problem with you where we're going to use this factor theorem to help us factor a polynomial and, as a result, find the zeros or the x-intercept for that polynomial. So head on over to the next page of notes and I'll meet you guys there.